Woo, hello, hello. Welcome to Back to Basics. Let's get this done, right? Let's get this done. Okay, so this is like terms, distributions, and expressions. Go ahead and download this file in the descriptions. There's a PDF. Print it off. See what you can do. Come on back, and let's see what you did. All right, when I combine these terms, I'm adding them. Positive 15 plus negative 29. I have more positives than negatives. Sorry, I have more negatives than positives. So when I take 15 of those positives away from those 29 negatives, I'm left with 14 negatives. A negative times a negative is a positive, and 9 times 8 is 72. A positive divided by a negative is negative. 64 divided by 4. 4 goes into 6 once with a remainder of 2. 4 goes into 24 16 times. Well, 6 times. All right, now I have 6 negatives, and then I'm going to subtract 17, so I'm getting more negative. So 6 and 17 is 23, but because they're both negatives, it's negative 23. On this one, this is a base raised to a power, so my base is 13, my power is 2. This means take the base and multiply it by itself 2 times. So that's 169. All right, this one is tricky because the negative is not being taken to the power. Only what is directly below the power is being taken to it. So the negative just stays out in front, and then I apply the exponent to the 8. And 8 times 8 is 64. All right, here, notice the exponent is in parentheses. So that means I'm going to multiply negative 3 times itself 8 times. 1, 2, 3, 4, 5, 6, 7. I need one more. Okay, there's no way I'm going to sit here for that 20 seconds and do that. So I'm going to go to my calculator, and I'm going to open a parenthesis, negative 3. Make sure that if you're using a calculator, make sure that the negative key you use only for negative, and the subtraction key, which is an operation, is only for the operation subtraction. They are not interchangeable in most calculators. So negative 3, exponent. Every calculator has an exponent key. There's my exponent key, and I'm going to put 8. And I get 6,561. Okay, now we're going to go to order of operations. Let's go ahead and look at terms. Okay, so terms are separated by subtraction and addition. So that's what separates terms. So I have 1, 2, 3 terms. I'm going to look at each term separately and simplify them. So negative 6 times 3, that's negative 18. Minus minus makes a plus. And then plus 24 divided by 6 is 4. Remember what this means. This means you have 24 M&Ms and you want groups of 6. So how many groups, what is in each group, right? So notice there are, so let me say that again. You got 24 M&Ms and you want 6 groups, right? That's what I said. So how many per group? 4 per group, right? It's an even distribution. That's what division is, an even distribution. All right. Now I'm just going to combine all these by adding them up. Negative 18 plus 10 is negative 8. Negative 8 plus 4 is negative 4. Very good. All right, this is order of operations, but there's this grouping symbol. The grouping symbol is a fraction bar. All right? So that means division. Like so. So I always simplify the numerator, the denominator, and any other term by itself first. So I'm going to simplify all of these things on their own, and then I'm going to bring it together. Here, I'm going to go ahead and do negative 8 times 5. That is negative 40. Plus 15 divided by 3 is 5. Negative 40 plus 5 is negative 35. So the top, which is called the numerator, is negative 35. The bottom is 6 minus 13. So if you start at 6 and you subtract 13, you go past 0 and into the negatives. And that's negative 7. Plus 20 squared. 20 squared is 20 times 20. That's 400. Okay, we're almost done. Let's go ahead and simplify our division. Because remember, the fraction bar means divide. Negative divided by a negative is a positive. 35 divided by 7 is 5. Plus 400 is 405. That was awesome. 405. Okay, we're doing great. Okay, refer to m to the 8th power. This is a nice exercise in identifying parts of a term and more an exponential term, right? Okay, so the base. The base is what's being raised to the power. So the base of m to the 8th is, what do you think, kiddos? M, let's go. Yell it loud and proud. M. The exponent is 8. Excelente, excelente. Okay, now to expand means you apply the exponent to the base. So, the exponent means repeated multiplication. So I'm going to take m, and I'm going to multiply it by itself. Holy Toledo, Batgirl. I don't know if I can get them all in here. 1, 2, 3, 4, 5, 6. Ooh, I'm going to make it 7, 8. That's how you expand a base and exponent. It just means it's a simple way of writing repeated multiplication. I'd much rather write that instead of that. So it's just a shortcut notation for writing exponents with a base. Now you're going to put it in exponential form. That means you're going to go from there to there. So notice your base is a. And now how many a's are you multiplying together? 1, 2, 3, 4, 5. So the exponent is how many a's are being multiplied together. Let's go. Let's turn it over to number 12. Oh, combining like terms, one of my favorite things. This is such an important concept. It's in every math class you ever take. Look for categories. So in that category is X, right? This category is Y. And then this category is constants. Notice how I always take the operation in front. Notice there's no number there. That means it's a 1. So 6 plus 1, that's 7. What's your category? X. Very good. Negative 7 plus 8. That's why this goes with it. It's not 7 plus 8. It's a minus 7 plus 8. And that's plus 1, y. We don't have to show the coefficient of 1. Coefficient is the count, right? How many do you have? 2 negatives and 13 negatives. This is like you owe me $2, and then you owe me 13 more. So you owed me 2, you borrowed 13 more. How many do you owe me? That's right, you owe me 15. Is that in proper order? Yes, it is. Alphabetical order. X comes before Y in the alphabet. All right, here we go again. All right, I have these H squareds. There they are. There they are. There they are. There's the same category. I have these H's. Boom. Boom. And then I have these wonderful little constant terms. Whoosh, whoosh. All right. Start with your H squareds. I mean, you can start with your H's. In fact, I'll do it that way, and then I'll put it in standard form when I'm done. So I'm just going to combine all of these. 7 and 11 is 18. And category, H. Negative 2 plus 5 is 3. 3 minus 7 is negative 4. Category, h squared. Now I have my constants. 12 minus 8. I think you know what that is. What's 12 minus 8? 4. Very good. That is not proper form. Notice the variable h is the same, so exponents have to descend. That's an exponent of 2. That's an exponent of 1. That has no h, so that goes last. Constants always go last. That subtraction turns into a negative when I shift that term to the front, plus 18h. And I know it's plus because there's nothing in front of it. If it was subtraction, there would have to be a negative in front of it. Plus quattro. All right, good job, good job. Let's go. Here's an A. Here's an A. There's no more A's. Here's a B. Here's a B. No more B's. Because B squared is not like B. Not the same category. There's a constant. There's a constant. Oh, I didn't really get this negative with it, so I'm going to go back. I want to make sure you see that. And then the last term, let's do it in green, is negative 7b squared, or minus 7b squared. All right, let's combine our A's. 4 plus 1. Very good. 5. What's your category? A. Nice job. Okay, 8 minus 9 is negative 1. You can show the 1, but you don't have to. B. Minus 9 plus 18. So there's more positives than negatives, so I'm going to take 9 of those negatives away, and I'm left with 9 positives. And then minus 7b squared. Okay, so those are all my terms. Now I got to do it in proper order. Alphabetical takes precedence. So A comes first in the alphabet. So 5A. Now we're going to talk about exponents. So notice we have the same variable b, but the exponent that is the highest goes first. This is called descending order. And then we have our b's, which will come after that. And that's minus b. And then we have that lone constant, plus 9. And you're done. The final answer has 1, 2, 3, 4 terms in it. Alphabetical order and descending when you have terms that have the same variable. Okay, another property that will never ever go away in mathematics, ever, distribution. When you see a number next to a parenthesis and you have multiple terms in the parenthesis, that's distribution. So you multiply negative 10 times m and negative 10 times negative 3. This is like 1m, so negative 10 times 1 is negative 10. Negative times a negative is a positive. 10 times 3 is 30. Those are not like terms because that has an m and that doesn't. Remember, your variable term always comes first. Constant last. All right, let's do the next one. I got to do the order of operations because it's a variable expression. There's no equal symbol, so that's what makes it an expression. Distribute the 5 through. So 5 times 4 and 5 times 6. 5 times 4 is 20, category X. 5 times 6 is 30. And now you just keep writing the rest. When the parenthesis ends, the distribution ends. Now that I've performed my multiplication, I can perform all my addition. That term is like that term. Woo, woo. And these two terms are like. All right. 20 plus 4 is 24. 30 plus 14 is 44. That's it. This one is tricky because notice that negative out in front. That's like a little negative 1. All right? And that's what we're distributing. I'm not distributing that. You only distribute what is directly next to the parenthesis. And so it's a negative 1. This comes straight down. It's its own term. Negative 1 times positive 15 is negative 15. Negative 1 times negative 3. Negative times negative is a positive 3 plus 15a. Because my distribution stopped because my parenthesis ended. All right, I got these terms that are like, hey. And then I got these terms that are like, Hey, like so. Okay, combine them. Negative 1 plus 3 is 2. Negative 15 plus 15 is 0. So it's 2. That was awesome. Okay, evaluate. This is new. This is a new direction. Evaluate. That means you have to substitute numbers in for the variables and then perform the order of operation. The word simplify means perform the order of operations. Evaluate means substitute and then perform the order of operations. When I substitute, I use parentheses. Notice, P is negative 3. So there's a P and there's a P. S is 7. There's an S and there's an S. All right, let's substitute in. PS means P times S. I like parentheses. I think they're great, especially when I'm substituting in. I make a lot less mistakes if I use parentheses. Minus. So now this operation. Sometimes we get lost, right? We got to make sure that these operations stay there. This is another reason why the parentheses are really important, because you're squaring all of P, and all of P is the negative and the 3, plus S, and S is 7. Okay, that's the first part. Now, we're going to do order of operations. Okay, let's talk about our terms. I think this is important. Terms are separated by addition and subtraction. So, there's a term, and there's a term. Okay, negative 3 times positive 7. Negative times a positive is negative. 3 times 7 is 21. Minus negative 3 squared. Let's make sure we understand what this means. Because the 2, the squared, the exponent, is above the parenthesis, everything in the parentheses being squared. That is a positive 9. Plus 7. Negative 21 minus 9 is negative 30. These are negative and these are negative, so you add them up and put the common negative in front. Plus 7. Negative 30 plus 7. Take 7 positives away from those negative 30s, and you're left with negative 23. Let's go. Identify the coefficient. The coefficient is how many you have. It's the count, right? If you have 7 M&Ms, your coefficient is 7. If you have negative 9xy, your coefficient is negative 9. So the coefficient is the number. How many do you have? Is 12 divided by 6 the same as 6 divided by 12? That would mean division is commutative? Well, 6 divided by 12, 12 divided by 6 is 2. 6 divided by 12, that's 1/2. Are those equal? No. So division is not commutative. When you add a positive and a negative number together, is the result negative, positive, or either? So you're adding a positive and a negative. Okay. I think I better write this out as an example, because I'm not sure what they're asking, but I believe they're saying, look, if you have a positive 6 and you're adding to that a negative 3, the result is positive, okay? But what if I change that? What if I did negative 6 plus 3? Well, now my answer is negative. So I could get a result that's positive or negative when I add a positive and negative together. So that means it could be either, depending on which one has the largest quantity. Okay. Well done, kiddos. Well done. You are so strong. Stay that way and everything will work out. Remember, work always comes before play. Always. So get your work done and then play. Stay strong. Do math every day. Woo, be good.